Welcome everyone to the third mini challenge final. We have three amazing teams today that will present their ideas. And we also have an interesting keynote that we will listen to later on by Frank Rudzicz. I hope I'm pronouncing. I tried before. I practiced before to pronounce this, but I think I probably still got it wrong. So I'll allow you to introduce you later on to tell us how it's properly pronounced. We also have, just for everyone, a reminder, if you don't know, we'll have a quiz. It's a very short quiz, 3 simple questions about the presentations. So you should pay very close attention to what the teams are presenting. And then you have the chance to win Surface headphones if you're the fastest with the correct answers of the quiz. So pretty easy prize for you. And then, of course, for the winner of the finalist teams, you'll win each Surface Go. So each of the team members for the first prize. So yeah, good luck to you as well. I'll also give a chance to UTMIST Robert to maybe talk a little bit more about this challenge, your organization, our collaboration, as we partnered for this mini challenge with your student association, and for the topic of this challenge of language processing and AI in conversational AI. So Robert, leave the floor to you to welcome everyone on your end as well.
All right, thanks, Lisa. Is my mic working?
Yes, it's working.
All right, good afternoon, everyone. We're the University of Toronto Machine Intelligence student team, a student organization devoted to promoting a vibrant machine learning community on campus and connecting students with graduate students, professors, and industries in AI, essentially to clear the mist around machine intelligence to help the eager young minds. So our activities, particularly this year, include an online course, academic and industry events, and projects that prepare our students for a career in engineering and research. And we partnered with Microsoft and Agorize in organizing this event because we believe that we can help all Canadian students have this opportunity as well. Thanks, Lisa.
Great, thank you. Well, we're really excited that we were able to organize this event with you and And so with that being said, I'm also going to tell you how the quiz later on is going to work, because we're going to use Slido. And just to make sure that everybody has joined it and can exit it, I actually going to take over the screen share because I need to show that on my end. So now you should be seeing my screen. You can join either at slido.com hashtag Discover AI 3, or you can just scan on your phone this QR code. And I'm actually going to be starting the first poll just to make sure that you can connect and that you can type into it. So just let us know where you're connecting from. Also, because this was an international challenge, of course, we're eager to know where everyone is connecting from. Me, on my end, I'm in Germany, in Mainz. I don't know if anyone knows that, but it's close to Frankfurt. So I'm sure we'll have a few people in Canada. I can see that. Calgary, Toronto, Montreal. So yes, the majority is definitely going to be in Canada, as this was mainly targeted in Canada, but since it was open everywhere, I see we have somebody from Dallas and Texas, so USA also represented. And let's see, wait a minute, let's give people a chance to answer. But yeah, I see a lot of Canadian cities coming up: Mississauga, Windsor, Calgary. Let's see what other people are entering. Brampton Squad. Great to have you here, Brampton Squad. Great. So I'll just be leaving this open. So we'll have later on, if also on using Slido, we'll do the quiz. So yeah, make sure you're already connected now. So you know, for the quiz later, you're ready to go when we start. So you won't lose any time. I'll just leave this open and go back to actually the slides. So while you're joining and entering your cities, I'm just going to give you a reminder, as I did already before, of the prize. So the winning team will take home a Microsoft Surface Go. I believe it's the second edition already. So you'll be taking home that prize. Good luck to you. And I also would like to introduce us to our judges. We have quite a big judges team this time. And I'm just going to invite each of them to very quickly, 30-second each, introduce yourself. And we're going to start with Heta. If you would please introduce
yourself. Sure. Can you hear me?
Yes.
Great. So my name is Heta, and I'm moving on to my third year of computer engineering at the University of Toronto. Right now, I also serve as the Vice President of the Academics Department at UTMIST, and I work as a data scientist intern at Bell Canada Enterprises.
Great. Welcome, Heta, and thank you so much for supporting us.
Thank you for the support today.
Next, we have Ash.
Yeah, hi. So my name's Arsh. I'm currently in my PUI after studying and currently studying the machine intelligence major in the engineering science program at the University of Toronto. And yeah, I'm really looking forward to judging and seeing what great submissions that the contestants have put forth.
Great. Well, great to have you as well. I'm not sure if Manav is here by now. If not, we're going to continue with Brian.
Hi, can you hear me?
Yes.
Okay, cool. Hi, my name is Brian. I'm going to my fourth year. I'm doing a math specialist and a stats minor. My experience with machine learning is that currently I'm working on a research paper with a graduated PhD from York, which is focused on image processing and facial recognition. And yeah, looking forward to this.
Great. Very happy to have you as well. And excited to hear also what you have to ask the teams later on in the Q&A session. Perfect. So next up, Caden, would you please introduce yourself?
Hello, can you hear me?
Yes.
Hello, everyone. My name is Caden McKean, and I'm a fourth-year computer science specialist at the University of Toronto. I'm the Director of Education at UTMIST, where I run a course teaching UFT undergrads about practical machine learning. And I'm also a machine learning engineer at Alice Insights forecasting climate change. And I'm really looking forward to your guys' presentations.
Thank you so much for being here today, Caden. We have next Kelsey Ann, if you would please introduce yourself.
Hello, everyone. I'm Kelsey. It's nice to see all of you in our meeting today. I'm the odd one in, I would say, the judges panel because I am an art and communication student. I am a marketing director for the Developer Student Club UTM. And I have seen projects like this before because I have worked with other companies like Under Armour, Burberry, Nike, Adidas, and I've seen projects similar to this. And I know I know how to execute it in the real industry. So I hope to see that all of your projects are also as stellar as what the industry offers. And I'm looking forward to seeing all of your projects.
We definitely also hope that all of these projects are stellar. I mean, I've already seen a little bit from their submissions, but I'm also excited to see how you're going to pitch your projects today. Okay, great. So last in line, we have Mohammed. Are you with us? Okay, so I guess we're just going to continue. Manaf and Mohammed are going to join a bit later, or if not, we do have 5 amazing judges with us. Great. So just a reminder before we go into the pitches, which is going to be the main focus today. 5 minutes for the pitch each. We have 5 minutes Q&A. The evaluation criteria are the quality of content, quality of presentation, audience engagement, and practical implications. So these are the criteria that the judges are going to use to vote and rank your projects later on. Also, a reminder to everyone in the audience, again, you have the chance to win Surface headphones at the end of this, as we're going to do a little quiz, very simple quiz, only 3 questions, 1 per team, that you can win if you answer them quickly and correctly, of course. So make sure you pay attention. It's, well, it's not too much into detail, but it is, some of them are a bit into detail. So you should make sure that you pay attention to the presentations. And with that being said, we're actually going to go in the first pitch already. And we are going to start with Geyser Sharan, please. So if you would like to, I think Matt and I'm just gonna spotlight you, and please start sharing your screen. Perfect.
See anything?
Yes, we can see it. Right now it's not in slideshow. Yeah, okay, it's in slideshow now. And there's the gray box again. Maybe you should just
oh, yes.
do that again.
Goodbye.
Perfect. Okay, so I'm taking the time.
Okay.
You can go whenever you're ready. I'm just gonna stop it, and if you take longer than 5 minutes, I'm gonna stop you as well.
You ready?
Yep.
Yeah.
Let's go for it.
Okay. So hi there. I'm Matt Geyser, and I'm a software engineer. I'm here with who's a good friend of mine, who's a data scientist. And we think we can use artificial intelligence to help difficult to engage with groups access government services. COVID has exposed a problem with government assistance. Even as we move things online, many people do not know how to access these services due to language differences, literacy challenges, or difficulty with numbers, which are often used to label government forms or required for benefit calculations. Only 15% of people who are unemployed in Arizona during this whole COVID-19 pandemic successfully navigated the unemployment system. 5% of elderly people never get their pension or Social Security money. 10% of people eligible for low-income health benefits do not get them either. A lot of this is simply because people cannot navigate the bureaucracy, or often do not even know what benefits are available to them for their particular situation. Government services are not easy to find or navigate. We think that NLP can help solve that. Currently, locating and finding information is based on keywords and semantic connections. That's how Bing works. But unless you know what to search for, you are out of luck unless someone has gone out there and done proper search optimization, matching the keywords that you might ask in a question and linked that question to the problem in an article. But people do not start out with a solution and then need to figure out the details. At least that isn't the only way that they find ways to solve a problem, but rather start with a problem and need help knowing what solutions are out there that might help them, if any. An unemployed person might not know that they should apply for benefits, or even if they do, all they might know is get money for being without a job, which if you search this turns up nothing related to unemployment benefits, but rather Uber Eats and newspaper delivery. So the goal of this chatbot would be to create something that allows those people to start with a question and a problem, and for natural language processing to map their questions to predefined scenario maps. The askers would then be guided through these scenario maps, and common questions that couldn't be answered by the bot would be saved for future answer by the administrators. Ideally, the chatbot would be done through SMS, as that's what many low-income people have available, as plenty cannot afford the latest smartphones, which could run web apps.
A large part of the current problem is that there is no centralized place to start the search for government programs. If you have a problem, where exactly do you go? In Canada and the United States, every bit of land has 3 levels of government, if not 4. Once you start adding in independent departments, school programs, and private-public partnerships, the patchwork of programs for any given challenge is enormous. what happens is that people try a bunch of different ways to find information and end up in a bunch of different places as a result. Ideally, we would want to funnel everyone who is having trouble through a chatbot process. This would make it seem like a normal conversation with a customer service agent, except this customer service agent is far easier to scale and can very quickly be taught the various programs that are locally available by filling out schema files. It can also keep track of the queries that cannot be answered automatically and pass those on to humans for answers. So we have 3 key goals. Number 1, help people access government programs that could provide solutions to the problems they face. Number 2, one of the barriers for many new citizens is language. So well-written software is easy to modify for use with various other languages. And number 3, governments in North America are very fragmented and lots of smaller communities have no resources for larger projects. We tech people are not cheap, making software projects very expensive. But a chat box could easily be modified for them at a low cost. And yeah, that's basically our project. Thank you so much for listening, and please let us know if you have any questions.
Perfect. Thank you so much. You did have 1 minute left, but that's great. You did a great job. Thank you so much for sharing. With that being said, it's time to bring our judges on the stage as well. So please let me know, just raise your hand, judges, so I can call you out. And then I'm going to ask you to ask your questions. Yes, Hita, please.
Sure. Can you hear me?
Yes, I can hear you.
Great. So my question was, I understood that this particular project was kept with North America in mind, but I just want to know what you think about the scalability of such a project to a worldwide level.
It could probably be scaled to a worldwide level as well. It depends on how people mostly communicate, whether it's through SMS or maybe we'd want to integrate it more with Facebook or WhatsApp. But the basic concept, it would be the same of okay, I have this problem, what can you do for me? And you'd be going to the technology to ask that question and outline your current situation. And the goal of the chatbot would be to take you from your current situation to something better with the goal of a government program.
Right, that sounds good. Thank you.
Great. So do we have any other questions, judges? Ash, I think. Ash?
Yeah, hello. Can you hear me?
Yeah.
Yeah, hey, okay, yeah. So, I was just wondering about what are some technological hurdles in terms of technical implementation that you feel like you'll face in, for example, the implementation of a SMS chatbot?
Probably the largest is just making sure that we can get it to work with all sorts of different ways of asking the same question. So can we figure out all the different sentence structures and such that people might use to really represent the same thing? And the other challenge would be making sure we get enough diverse data from various different cultures of how they structure language to make sure that it can work for a wide enough group of people.
Okay.
Great, thank you. And we have Kaden as well for the question.
Hi. So I was just kind of wondering, sort of from the last question, have you guys sort of committed to kind of like a pattern matching sort of type setup, or are you also considering a couple other avenues?
We haven't gotten that far in the process yet. It was mostly, this is the concept and we believe it can be done with the existing technology.
Got it.
Great, so we have time for at least one other question. So, dear judges, if any of you has a question, now is your time. If not, oh, I see Robert has a question. Well, yeah. I guess I'll let you go. You're not a judge, but let's hear it.
I'll take it.
Thank you. So my question is regarding the marginalized and underrepresented communities in many of our societies. So obviously there are common barriers like language and technological skills, but then there's also like kind of there might be cultural barriers as well. So in what way might your solution address these challenges for underrepresented communities and those who are often forgotten?
That would really depend on the particular cultural barriers. For some people, it's just the challenge of asking for help. They don't want to ask for help too directly. So you'd want to have it so that they can give you a more generalized program. You have to make it so that it's not looking for things like, I am unemployed, but what are some options for people who do not have a job? So you want to make it so that it's less direct about their circumstances, for example. Yeah, we haven't looked at that too in depth at the moment, but it's definitely something we should do.
Yeah, I just want to add in, if to hit those smaller minority groups and stuff like that, if we can collaborate with some representatives from those groups, then we'd be able to better understand their specific communication styles and just little intricacies, and just get a better understanding about that, which we could then be able to use in our chatbot system.
Great, yeah. Perfect. Thank you, guys. I guess since we still have some time, I'll just leave it up to the audience in general. If anyone has a question, please just raise your hand. And by raise your hand, I don't mean actually raise your hand like this, but raise your hand. There's a little button that's called raise hand that you can use. If no one has any questions, I don't see anything. Well, then I guess I can just now everybody actually can do it. We can just give a little, since we're not together, we can just give a little virtual applause by clicking on the button, and I can actually applaud you like this. Thank you so much for your effort. Thank you for participating, and now it's up to the judges, of course, to vote for you. And we'll move already to the next team, and that team is Nova. So I think Aditi and Niyati.
Yeah, hello.
Can get ready. And just start sharing your screen.
Okay, so hello to everyone. My name is Niyati, and I'm here with my partner Aditi. So without any further ado, let's get right into our video and project.
So yes, if you want to, you can go ahead.
Sorry, give me 1 second. It doesn't seem to be working. Okay.
That's what a friend of mine sent me yesterday. 86% of online users around the world believe they have been exposed to fake news, and more than 8 in 10 of them report having initially believed that the fake news was real. This is pretty bad. Fake news can be weaponized to influence politics, economics, and social well-being. In just 3 months into the coronavirus pandemic, at least 800 people had died because of fake news on the coronavirus. Now that we've established that this is bad, what can be done? Well, today we have two students here to discuss how AI can play a key role in this crisis.
We are Team Nova, and we built a natural language processing project to identify fake news from real news.
How does it work?
We built our project on Jupyter Notebooks, and we began by importing all the necessary libraries. Step 1 is data collection, which entails collecting news articles and labeling them as fake or real. The data for our project was obtained from Kaggle, and it consists of news articles labeled as 0 for fake and 1 for real. We can explore the title and text of some articles along with their label. Around 52% of the news articles are fake and 48% are real.
The next step, called data preparation, involves preparing the labeled data by normalizing it, packaging it up, and splitting it so that it can be inputted into the model. For our project, we removed publisher information to prevent the model from learning to classify samples with that information as real, and we also removed URLs, punctuation, and the most commonly used words, also known as stop words, since all of these don't add much value when analyzing text data. We also converted the text into lowercase form and turned all the words each article into a dictionary form, so they can be analyzed as a single term with the correct meaning through lemmatization. We had a total of 65,698 labeled samples that were split into 60% for training, 20% for validation, and 20% for testing. The testing dataset is used by the model to learn. The validation dataset is used to provide an unbiased evaluation of an in-progress model, and is used to fine-tune model parameters we can control. The testing dataset is only used as an unbiased evaluation of the final model at the end. In data pre-processing, we tokenize the text by splitting it into individual words and create a word index that maps words to a numeric vector representation. Then we encode the text into sequences that correspond to the word index so that AI models can perform mathematical computation on them for analysis.
The third step in the machine learning process is choosing an AI model. We chose the LSTM model, which is a type of recurrent neural network capable of learning order dependence in text. In comparison to regular RNNs, where the outputs from previous steps are fed as inputs to the next step, LSTMs are able to process the text data using internal operations that allows it to keep or forget information from the text as most appropriate. Our model consists of an embedding layer that converts text sequences created using the word index into a numeric vector, such that similar words are close in the vector space. Then we have two LSTM layers with a dropout layer in between them, and two dense layers.
The next step is training the model on the training dataset and evaluating its performance on the validation dataset. We trained the model on 15 epochs, so our model had the chance to learn from the training dataset 15 times. Our accuracy plot shows the model is performing well, and the loss plot shows it makes less mistakes over the 15 epochs.
After training, we evaluate the model. The model has not seen the testing dataset before, but it was able to predict if the news articles were fake or real with a high accuracy. The confusion matrix shows the model's performance by counting articles the model classifies correctly and incorrectly according to its prediction and the actual label.
Parameter tuning comes after you have done one run of all the steps. Certain parameters like the number of epochs or learning rate can be changed to improve the model further. We perform this step while building the project. And the final step of the machine learning process is prediction, which means getting the model to predict on real data. We tried our model on recent articles we found online and a few articles from fake news sites, and here are the results. We even tried the model on your friends' articles and got the correct results.
Oh, that's interesting. What can be done for this project in the future?
We believe this project can be turned into a tool, maybe a web app, a browser extension, or a phone app that everyone can use when browsing the web or scrolling through social media. This tool will process the text on the screen and classify it as real or fake and display a warning to the user. We hope to see this approach keep users more informed and limit the spread of fake news around the world. And in a digital age, as more people join the web, this task becomes crucial to prevent the catastrophic impacts of fake news.
Cool. Thank you for sharing, Team Nova. That ends our segment here. Thank you all for joining. Bye-bye.
Thank you so much. Thank you for your video. And that was right on time because your video was exactly at 5 minutes. I'm hearing an echo for some reason. So maybe you can just mute yourself. Great. So thank you for your presentation. Now it's time to ask the judges again if you have any questions. Can you please just raise your hand like we did before? if you want to ask Team Nova some questions. And we have the quickest again, Hita.
Sure. Can you hear me?
Yes.
Great. So my question was regarding a common problem that's faced in NLP. So sometimes the text that you get can vary from the region or the source of the data you have, right? There could be different dialects and different regions can have different styles of writing. So have you considered the scenario where, say, suppose your model is trained on the data of, say, North America, but if you say deploy it in another continent like Asia, how are you going to deal with that?
So in terms of, you're asking in terms of different languages or just the way English is represented in different forms in different countries?
English is represented in different forms in different countries.
Sure. So with that, I think we would definitely need more data in terms of where we're trying to deploy this tool. So for us, this tool, the data that we got was from Kaggle, and it was taken from websites like Reuters News for actual news, and then fake news sites. So it's more based in America setting. For now, it would have to definitely be in a North America setting where the form of English is in the sort of what we're used to in North America. But moving forward, it could definitely be using data or news sources from different countries in Asia or in Africa or in Europe, anywhere there. We could take data from news sites that they have and train our model on that, as well as I think we can actually, moving forward, we can also use translation to do it in different languages for countries where majority of the speakers are speaking another language or their news articles are in a different language than English.
That was really descriptive. Thank you.
Great. Thank you, Aditi, for your clear answer. The next person that wants to ask a question is Kaden. Kaden, you can go ahead.
So I know you guys.
I'm having trouble hearing.
Fusion matrix. Sorry. Am I breaking up?
Yes.
It's better now.
Maybe you just start
Okay.
over. I think it just took a moment to adjust for some reason.
Okay, sorry. Yeah. I was just kind of saying, so I noticed your confusion matrix. Would you say that false positives are more dangerous or false negatives for this application? Have you kind of considered that?
I think in terms of, we haven't really thought about that at this point, but I think we can probably do more analysis on this and figure out what exactly in terms of look at the samples that the model is getting incorrect and look at what patterns there are available in that and try to eliminate those issues and like try to see what other ways we can pre-process our data to get the right results and see exactly figuring out what changes we can make in our model to detect those patterns. If there's any way we can detect these complex patterns or anything like that would be, I think, our next step moving forward with this.
Thank you.
Thank you, Kaden. And next up, we have Ash.
Hello, can you hear me?
Yep.
Okay, hi. So yeah, it was a great presentation. I just had a question regarding, so in terms of like what you began with thinking about, for example, was your goal or is your end goal to build like a fake news classifier, or is it to like how do you think that the model that you built that classifies whether fake news or not, how do you think that people can use that model, or how do you think they should use that model in their daily lives?
So just on a general note with fake news, especially with all the vaccine stuff going on with COVID-19, it's a really big thing with if you look at the history of MMR vaccines and the link between MMR vaccines and autism, it really caused a big problem. So the overall idea with the digital age, everyone is more people are going on the web, and there is definitely because I was trying out different we were searching up like different fake news articles, and there were multiple sites
sites like this that have these fake news articles, and a lot of these articles end up on, let's say, Facebook or Instagram or different sources like this. So the overall idea would be to use this app. It could be a web application, a phone app, or like a Google Chrome app or anything like that. Where the overall idea would be if someone's scrolling through content, they can figure out from like an indicator that tells them if it's fake or not, or how fake it is, or if they're real news articles that have debunked this myth around this is fake news, this versus this isn't fake news. So at this stage, it would be more of like, here, this is an article, and the user would input the text into the system, and then we can help them classify if it's real or not. But moving forward, this is definitely an approach to take, where if they're scrolling through content, they can easily see if this content is fake news or if it's real news, and what percentage, if that's a possibility, to figure out what percentage this is fake and this is news. And then moving forward, even more research can be done on using, let's say, YouTube videos. So from YouTube videos, getting transcripts from the YouTube video and analyzing that and seeing if YouTube videos are presenting this fake news or presenting this fake content around it. So an overall perspective, I think bringing this tool for everybody to use on their daily lives would be an ideal way of kind of combating the catastrophic effects of fake news.
As a follow-up question, did you have this vision from the start of your project, or has it evolved since then because you may have realized the capabilities of your classifier? Just wondering about that.
I think it was from a beginning perspective where this is what we want to do, but how can we simplify it at a stage where we can build it right now? And then moving forward, it being able to think about what are some ways this can be improved even further, or what would be the ideal situation. I think we started off with the ideal situation, getting an idea of, okay, fake news is a problem, especially with vaccines going around right now. How do we combat that, and bringing that forward with the project?
Okay, thank you.
Sorry, I did the common mistake. I was muted. Thank you, Ash, for your question. We have time for one more question. I see that Kelsey has one. Actually, I think, yeah, Kelsey. So Kelsey, if you could please unmute yourself and ask your question.
Thank you. First of all, amazing project. I also do think that fake news is a big problem, especially as a communications major. I know this year I've had to write a really long essay about the implications on fake news on the coronavirus. So I understand where both of you are coming from with regards to how big of a problem this is. But I want to understand the practicality of it, right? Would you need someone or something on the back end to analyze each and every article to determine if it's fake news or not? Because if this is a manual process, right, then it would take forever for you to classify an article as fake news. And by the time you classify it as fake news, it would have already made its bad impact, right? So how do you see this? How do you see these articles being analyzed to be classified as fake news?
I think in the initial stages, with AI models, what we can utilize with an AI sort of system is that we don't need to train on we don't have to train on every single article that's out there. We don't have to classify it ourselves like this is fake, this is real, this is fake, this is real. We don't have to do that right for each article. What we can do is take a subset of the articles in the entire world and train our model on this, so it starts to recognize patterns around, let's say, people saying vaccines cause some sort of illness or something that doesn't relate to anything related in the news that's available already. So discovering these patterns through AI and building a model that is able to detect these patterns and understand these complex relationships between the different types of text that are used, we can try to figure out what if an article is going through our system, the AI model can predict, using just on the spot live prediction, be able to predict if this article would be a source of fake news or a source of real news. So this won't be more of a manual process. It would be on the spot, a live process. I'm missing the word, what exactly it would be, but it's more of a live process where the model does this instead of a human sitting down and trying to classify each of these articles. Does that answer your question? Okay.
Okay, great. So that was all the time that we had for questions. So again, I'm giving you a little applause. So please feel free, everyone, to virtually applause for Team Nova. And with that, we are already, it's already time for our third and final team, INF Tech. I think we have Tavi presenting. So if you could just start sharing your screen.
Hello, Lisa, I can hear you.
Perfect.
Is my screen visible?
No, I think it's coming up right now. Yeah, we can see it. So yeah, whenever you're ready, feel free also to just quickly introduce yourself before you start. And then whenever you're ready, I'm going to be taking the time.
Yes, I am ready. Meet our team. The name of our team is Invented. This is Tohid Ahmed Kamal from Daffodil International University. We have another member, Jafrin Al-Mustari. We both are from Computer Science Engineering Department. So conversational AI. Conversational artificial intelligence combines natural language processing with machine learning. Conversational AI refer to technologies like chatbots or voice assistant which user can talk to. They use large volumes of data, machine learning and natural language processing to help intimate totally human interactions, recognizing speech and text inputs. Natural language processing. Then, well, what's natural language processing? I can explain this with this animated GIF. Suppose you are saying Alexa to what it's time. Alexa will reply, it's 2:30 p.m. Suppose you are watching a YouTube video, it will automatically generate the captions. All of these are the example of natural language processing. Our idea and prototype. We invented have brought up a solution which name is Regreen. Basically, this was our startup, and we tried to implement the natural language processing in this startup. And our idea was to provide plant and planting equipments in exchange of recyclable waste materials like glass, plastics, and papers, which will improve our environmental status, and it can make our environment sustainable for future generations. We will provide plant in exchange of waste materials. In this process, if anyone can gather plastic bottles or recyclable bottles, then we will provide planting equipments or even plants. Well, that was our just normal idea, but what we implement artificial intelligence, why we implement artificial intelligence or conversational AI? We implemented it in a chatbot. The chatbot will provide remind based on weather forecasting data using machine learning, and it will suppose it's 10 a.m. and you have fixed, or it will automatically guess that you have to water your plants, and suppose the weather today is too hot and the temperature is rising and it may be at the highest peak, and then the chatbot will recommend to water your plants, or maybe your plants are having less nutrients, then it may suggest to provide nutrients, or it may also provide guidelines based on weather forecasting data, etc. Here is the functionality and workings of chatbot. We have worked it in Python, and we have also another idea to guess that whether the plants are good condition, or in for that we are using the AI implementation for that, so that it can detect that our plant are having any disease or etc. And it will predict that our plant are having any kind of diseases. Here are we are using Keras model for this, where our AI model can detect what kind of disease the plants are already having. However, we will provide guidelines we have already described it that based on weather forecasting data, it will provide guidelines whether we need to water the plant, or these guidelines can also be described by reminded by our chatbot which we will provide. And all of these are our chatbot. The technology we are using is basically natural language processing technology. Thank you very much.
Great. Thank you so much, David. Thank you for your presentation. And I do feel we have Safir on the call as well. So congrats to both of you for making it this far, and for hopefully you learned something as well on AI through this challenge. Now it's time again for the judges to ask their questions. So please raise your hand again if you have any questions. Yes, Caden, please.
Hello, great presentation. I was just kind of wondering, could you give us a few more technical details just about your NLP model? So I understand it's kind of for telling you to water your plants and whatnot, but I was sort of wondering about the inner workings a bit more.
Sorry, but if you are saying about the NLP model, then I can't describe that too much as a beginner. I'm totally a beginner, but I have tried to learn something from and tried to put this presentation.
Okay, well, thank you, Caden. Thank you, David, for your question. Do we have any other questions? Yes, heads up, please.
Right. Can you hear me?
Yes, I can hear you.
Yes, I can hear.
Great. So my question was somewhat similar to Caden's. Why do you think you actually require an NLP model for giving details about the weather? Like, have you considered or explored the possibility that you could actually just get the weather, the live weather data, and maybe just hard code the solution, because that's possibly one of even a acceptable solution.
Yes, it could have been easily done by the just normal AI model, but why we are using NLP? For natural language processing, our chatbot can sometimes it comes that when we need to train our model, that when it's asking, suppose one user asking for the model, that chatbot, that sorry, I can't answer this. I have little less knowledge about this, and just first year university student. And
that's all right. That's all right. That's why we're here to learn something. So great that you participated, and hopefully you took something away from that experience as well. I don't know, judges, maybe we have a few less technical questions for this team. If not, maybe I can in that place I can ask you something. So you talked a bit about okay, so you want to do something for climate change, but who do you think is going to be the people using the well? Who are you developing that application for? Who do you think is going to use it?
This application can be used by people around the world. You may say that how can we gather those waste materials? We can collaborate with organizations, or it can be volunteering organizations, those are collecting those recyclable materials, or many companies in you can see these companies are in various very different countries. Anyone can collect this, and it could also be a business type.
So you're more likely you're thinking it's more likely going to be used by companies and organizations instead of individuals?
Yes, yes.
Okay, great. Well, if we don't have any other questions, I think we can close that question and answer session as well. Thank you so much, Tawhid. Well done for beginner projects. I think you can be really proud of you for developing that. And we will now, yes, we have the applause. I see some people applauding. I'll also give you a little applause. So now it's already the time for the judges to, and I think Tawhid, maybe you can just stop sharing your screen because I see my face really big, which is irritating. So yes, so the judges actually are going to go in the other room. So Calvia, I think she's assigning you judges, you know what to do. I think you will be receiving a message that you should go to the breakout room. So you're going to go there with my colleague Juliette to discuss the results, and we're all eagerly waiting for the announcement later on. While we're waiting, we have two things for the audience, for everyone that is not a judge. First of all, we are going to do the anticipated quiz that will allow you to win, as I said before, Surface Go headphones. No, wait, always, okay, so you can win Surface Go headphones, and I'm just gonna be switching to, yes, let's go here. So if you haven't joined it yet, we have a little bit of time for you to join the quiz. So I'm not sure if it's, oh yeah, so there's some people joining. So I'm gonna give you a minute to join. It's gonna take super little time because we only have 3 questions. And let's just give everyone a second to join. And then after this little quiz, we have Professor Frank Rudzicz, I'm not sure, he's gonna tell us in a minute, with his keynote. And he's actually an expert, I think, in natural language processing and AI. So I think we can learn 1 or 2 things of him as well. But I'm going to let him introduce himself in a bit and tell him his background and everything. So let's just give everyone a shot. I'll just wait a little bit longer to make sure everybody that wants to participate can actually participate. Because we do have, so there's 18 people here. I think we were around 40 people on the call. So yeah, just waiting. Great, 22. Yes. So usually I try to put on some music, but I had some technical issues on my end. So yeah, we'll have to sit in the quiet, or I'll have to keep talking to hide the quietness while we're waiting. Great. So 23 people. I'm gonna give it. So if you haven't joined now, you have 10 more seconds before we start. So hurry up, because I'm going to be moving to the next step very soon. And hopefully you all paid good attention to be able to answer the questions. Because in the end, we want to not only have, of course, the participants that have completed the modules and so on, and to learn something, but hopefully all of you learned something maybe about how AI can be used, in what many ways AI can be used. Maybe you got an inspiration of what you could think of. AI, there's so many use cases for it, and I think it's very certain that it's going to be in all of our futures, and maybe a lot of things you're already using it and you're not realizing that that's actually AI. Okay, so I'm going to be moving ahead. Oh, that was the last 25th person, like you, because I almost pressed the button. So let's go. everybody, I hope you're ready. You have 20 seconds per question, but then of course the person that answers the quickest is going to be the one on top, and we have a leaderboard after each question so we know who's leading. Okay, so this is for the last team. For what is Inventec using AI? To scan and classify recyclable materials, to give advice on how to treat plants, to analyze the effect on the climate of different plants. And let's see. Oh, okay. We have 52% correct. Do you know that in German, it's really weird because we say the numbers the wrong way around. That's why I just said 25, because that's how we would say it. Well, the other way around, we would say it in German. Yeah, tricky question, because I think the other ones could have been right as well, but they were just slightly not on spot. So right now we have Safrine leading, which I guess I'm not surprised because it was your project, but you can see that others are closely following. Smeet Patel, Michelle, Momo, and Aditi are on the first top 5 votes. We're going to move to the next question. So what is the issue that Gaila Sharan addressed? Lack of guidance on governmental service pages, difficult and long application processes for governmental support, or lack of information available in the internet. What are they focusing on? Okay, let's see. Okay, most people think it's lack of guidance on governmental pages. Let's see if that's correct. Yes, it is. And let's move to our leadership board to see. Okay, Smeet Patel, you took over. You had 16 seconds and both questions are right. And we see that the board changed a bit. We have Cordelia and Danielle Say that joined the board as well. So I think the last question is going to be the deciding one. And it's a detailed questionnaire. It is maybe a bit unfair. So let's see. How many steps does someone need to identify fake news with AI? Who remembers the different steps? Is it 4, 6, or 7? Okay, most people say 7. Let's see. Yes, 7 is the correct answer. And we have a winner, Smeet Patel. Congrats, you're the winner. Please just, contact us, share your, contact me at lisa.leibold@agorize.com. I'm going to post it in the chat for you. So you can just contact me and we're going to figure out the price and everything. So with that, we can go back to our event. And Frank Rudzicz, I'm going to ask you to come on stage to introduce yourself to us, and to then, we're very excited to, yes, you're already sharing your screen, to hear a bit more about natural language processing and your experience with that.
Oh yeah, this is my pleasure. You can hear me?
Yes.
So hi, I'm Frank Rudzicz. I'm a professor of computer science at the U of T and faculty at the Vector Institute for Artificial Intelligence. This is going to be a recycled talk. So I gave this talk in my role as the director of AI at a company called Surgical Safety Technologies. But I just wanted to mention that because it's sort of a conflict of interest. I receive a salary and stock from this company. And during this talk, I'm going to be mentioning some things that we're working on. So very quickly, I just want to jump through 3 broad topics. So we'll define what natural language processing, or NLP, is in general as a scientific field within artificial intelligence. Then we'll touch 3 core technologies in NLP briefly, hopefully with enough depth to retain their fundamental concepts. So we'll overview word embeddings, recurrent neural networks, and transformer networks. And then finally, I'll talk about a few applications of NLP that are already starting to transform how we deliver healthcare and in surgery specifically. So natural language processing is a discipline that combines linguistics, engineering, machine learning, and typically some domain expertise to process any form of recorded text or speech. So this can be emails, web pages, clinical notes, news broadcasts, conversations, whatever. So in fact, AI and natural language processing were born at the exact same moment. So in 1950, the genius computer scientist Alan Turing asked the question, can machines think? And because so much of our cooperation between humans is stored in language, the test he proposed, which has since evolved but really hasn't been replaced, is really entirely based on a computer's ability to mimic a conversation, to fully understand and produce realistic language. So language is at the heart of the question of whether machines can think. But 70 years later, NLP is still probably one of the most challenging areas in AI. So for instance, language is complicated by shorthand, acronyms, spelling, or speech errors, various kinds of ambiguity, metaphors, uncertainty about how concepts relate to each other, and so on. But fundamentally, we still don't even have a language for what we're trying to measure. So in computer vision, it might be somewhat easy to define what a stop sign looks like. It's a red octagon and it says stop on it, but we really don't have a similar sort of absolute description of what a concept should look like, so to speak. So NLP is a sub-area of artificial intelligence, and it uses an awful lot of machine learning. And there are various sub-areas of NLP itself. So there's a conference deadline coming up in a few weeks in computational linguistics called the MNLP, and the call for papers for that conference has at least 25 subtopics, which doesn't even really scratch the surface of all the different ways that natural language processing can be applied. That being said, the sub-areas of NLP tend to focus on tasks or applications, so things you can do with language. These are familiar topics like information retrieval, which typically involves data mining or like search in huge data sets, like Google does with the web. Or machine translation, which converts speech or text from one language to the equivalent in another language. We synthesize artificial speech. We recognize speech spoken by people. Interactive dialogue in the form of chatbots have started to invade our daily lives in the forms of Siri or Alexa. But more traditionally, NLP was used to label or classify documents as belonging to one category or another. So is this tweet from somebody who is happy or disappointed with a product, politically conservative or liberal, a bot or a real person, like we heard today, if it's fake news or not. But this just scratches the surface, of course. There's an awful lot of linguistic and cognitive theory that is brought to bear on this and similar problems. So I just want to go and dive very gently into 3 core concepts in NLP that are used across all of these applications and some others too. So first, a major breakthrough of the past 10 years or so has been to realize that we don't actually need to spend a lot of time and money explicitly hard coding a lot of information about language. Instead, we can use statistics to uncover these patterns for us automatically from data. So one of the easiest statistical models we can learn is one that we all have on our phones, a model that uses probabilities to just predict the next word as you type. It sounds simple, but if we can just learn an accurate prediction, then as a byproduct, we actually have also automatically learned information about how words relate to each other, and therefore, to some extent, what they mean. So this shows a very simple neural network. Each circle is an artificial neuron, and there are many neurons in the bottom input row as there are in the top output row. And every neuron kind of represents one word in our vocabulary. So if we had just read the word anastomotic, for example, in a clinical note, we want to predict the probabilities of all possible next words. We just set the input word for anastomotic to 1, everything else to 0, and then information flows up through the network on artificial synapses until we get our probabilities for the next possible word, and then we output things that way. So all of this actually squeezes information through this kind of smaller hidden layer, which is similar to how principal components analysis works for those who have done some statistics. So this hidden layer in the middle kind of distills abstract, meaningful, but still implicit information about words. So once we've learned all these connections between these neurons to make accurate predictions, if we just want to represent a single word, we can just ignore the output altogether and focus just on this middle layer and call it the embedding. So for example, you can imagine that instead of having 300 nodes in this hidden layer, we just have 2. And now we have a 2-dimensional real valued representation of a word in astomotic, which we can represent in a graph. So this image is basically how a neural network sees words. Each point is a word embedding, like the one we just talked about, projected onto 2 dimensions. So an important thing to note is that words that mean similar things tend to cluster together. So cataract and cataracts, glaucoma, they're together down here. Tremor, weakness, and ataxia, they're together. These models aren't perfect, nor is the method of visualization perfect. So here, like dementia and dementias are far apart, and they shouldn't be. I should mention that in this case, word prediction was trained using electronic medical notes from the Mayo Clinic. So it makes sense that the neural network learned something about medical terminology. A different set of data would have learned an entirely different representation altogether. So the data really matters. So not only do similar words cluster together, but other patterns emerge. So this left graph shows an embedding learned from a collection of news from Google of about 300 billion words. And you can see that country is clustered automatically on the left and city is automatically on the right. But interestingly, if you draw a line from any country to its capital, it will usually be the same direction and length as any other such line between a country and its capital. So China is to Beijing as France is to Paris and so on. And the neural network learned these relations without being told anything about countries, cities, or places, or anything like that. The same analogies are seen on the right. So man is to woman as king is to queen, or brother is to sister, and so on. But unfortunately, these models depend greatly on the data, and if the data contains biases, then those biases will be learned. So a few years ago, researchers found that a neural network actually trained at Google learned analogies such as man is to woman as programmer is to homemaker, or as surgeon is to nurse, which is obviously the kind of relationships which we don't like. So if a model is going to be deployed in the real world, as is the case by several major tech companies, the result is that you might have higher paying job advertisements going to maybe men as opposed to women. So there's a whole sub area of NLP which is now working on methods to ensure that this machine learning is free of bias and it's safe and equitable and so on. Let's see. So how much time do I have?
I mean, you can talk a bit longer. I think that the judges have already come to a decision, but we haven't covered the 20 minutes yet. So just finish your presentation.
I might skip a bit. I'll skip to how I'm using some of these technologies. I skipped over some of the core concepts in modern natural language processing for the past 2 years. So I'd recommend everyone look to the web for topics of recurrent neural networks, or these things called transformer networks. BERT is the most popular, which are sort of the cutting edge in natural language processing currently. That don't only represent single words, but can really represent words in the entire context around them, and can do so by looking at the entire context at once and paying attention to different parts, and to learn how to pay attention to different parts of the context, which is really phenomenal. And we have these new models, these transformer-based models that can perform better than humans on some tasks, which is quite a special thing. So I just want to talk a bit very quickly about the different kinds of ways that my lab and the companies are currently deploying natural language processing. We can attend to patients themselves. We can, learn their current status. We can build precise individual models for care. Secondly, we can listen to doctors and represent information that's not normally part of a structured, data set in a hospital. And third, we can use natural language processing to understand medical text generally, like we saw, which skipped over. So one of the main uses of NLP in health is going to be monitoring patients at home. So when a patient is discharged to their home, or if they're told to monitor symptoms that may necessitate, say, a surgery or coming to the hospital, NLP has actually been used to monitor symptoms through dialogue, for example. So speech has been even used as a biometric to track symptoms of, stroke or Alzheimer's disease, for example. There are dozens of commercial offerings in practice. So Babylon Health partnered with the NHS to replace a telephone helpline with an AI-powered chatbot. And there are hundreds of academic attempts to design chatbots to assess for different conditions, like diabetes, malaria, I mentioned dementia, and they've been applied to specialties like primary care, pharmacies, and so on. Chatbots have even been tested by the Veterans Affairs in the States to communicate with and help veterans with post-traumatic stress disorder, for example. So these chatbots can't entirely replace humans at the moment, who take histories and speak to the patients. And there's still some lack of sensitivity that can be revealed in the more vulnerable patients, but the technology is definitely already being used. So often it can be used in a way that the components of a note or a dialogue can be labeled and related to other components in an explainable way. So in this example from Amazon, the system is able to identify that Vyvanse is a brand name, 50 milligrams is the dosage, and the dosage specifically refers to the particular medication, so that other humans on the team can actually interpret the results, which is important. I mean, these machines are going to do better than humans on some tasks. Humans are still going to be part of the process, part of the workflow, or in the loop, so it's important that the results of these neural networks still be interpretable to humans. And finally, in my own work, we're using microphones in operating rooms to listen to the speech of the clinical team. So from that, we can listen for keywords to track progress, such as ensuring that surgical safety checklists are being done correctly, or we can listen to slight variations in speech to detect signs of stress or anxiety, to see if there's changing or unhealthy team dynamics or breakdowns in communication or so on. And it's along these lines that we're using speech as a means to assess for quality in the operating room, or even to diagnose adverse events using a product we call the black box. So just finally, there's an explosion of text and speech data in healthcare specifically, and often language is the only real repository of certain kinds of information. So using AI to analyze speech and text can give us all these new capabilities at a great scale that have never really been available in the past, but natural language processing is complex because of various intricacies in the language itself. And it's even more complex in healthcare, given frequent misspellings, odd structures, different vocabularies, and so on. So machine learning generally, it doesn't think like we do, and the errors it makes are different and sometimes more subtle than the mistakes that humans make. But as we move forward, we need to ensure that we want to preserve privacy, reduce model bias, take advantage of the benefits of natural language processing, such as increased flexibility, scalability, but also we want to build new capabilities we never really had before. That's it. Thanks so much for listening to me.
Thank you so much. That was very insightful. I definitely learned one or two things. Thank you so much. We do still have 17 minutes for the event, and we're not going to take that long for the announcement. So I want to give an opportunity to the audience to ask questions. So please, if anyone has a question, then you can raise your hand now, and you have a chance to get it answered. It doesn't seem to be like anyone has a question.
There's someone AM with their hand up.
Oh, yeah. Okay. Well, I don't know why I can't see it, but yeah. Well, then AM, if you want to ask your question, please.
It's a DT.
Hello.
Oh, a DT, yeah.
Thank you so much, Professor, for this amazing talk. My question is just about, what do you see as the future of NLP, or like an ideal future, or something that you're excited for in the future for NLP in medicine?
That's a great question. There's sort of like the field of natural language processing is sort of making progress on two main fronts, and those tend to be applications of natural language processing on one hand, and on the other side, more like fundamental theoretical kind of scientific progress. I think there's an awful lot we can do in both of those areas. I think even though natural language processing is being used an awful lot in practice now, it's being used more in very sensitive scenarios, right? So, if we're going to be making diagnoses for people in a healthcare setting, one, we need to be able to make sure that it's more important that we have accuracy is appropriate. We need to look out for issues related to privacy, which is a whole other kettle of fish. And again, I think I mentioned briefly that explainability is a huge thing, right? I think there's an awful lot of excitement in the healthcare community for artificial intelligence generally and for natural language processing in particular. But at the same time, sometimes when you're working with doctors, they're excited. You show them the outputs, but they don't care if your system is 80% accurate, 95% accurate, or 99% accurate, because they'll always be worried that there's going to be like that 1% of error is going to be more than enough to to make them lose confidence. So I think explainability and interpretability of these models are important ways to kind of move these things into practice. So to answer half of your question, on one side, questions related to how we actually put things into practice is still an open question. And through the company I mentioned and other companies that have sprung out of my lab, we're more interested in working on how to manipulate these models so that they can be more useful. On the other side, on the more theoretical side, I still think that dialogue is still the final frontier in natural language processing. We heard a little bit about chatbots today. It was the original task for artificial intelligence, but it's still, like I mentioned, the most complicated one because we still don't really know what we're trying to measure. To some extent, we can label text with classes, like this text came from that author, or it came from somebody with this political opinion. And we can even label words with maybe some other meanings, something that deep. But what it means to mean things in practice, or what we call pragmatics linguistically, that's a question we don't really have a good language for. There isn't a good a model from linguistics that can help us really understand how good dialogue should work. And that's why systems like Cortana or Siri or Alexa are usually built on these kind of handcrafted rules. You have engineers typing away and making sure, like with these regular expressions, that as many contingencies are dealt with. And that doesn't scale very well. And that's why usually these systems are used to just play the next song or turn off the lights in your room. So I would love it to make more progress, like on the theory behind dialogue, and that's going to involve linguistic theory. It's going to involve not just taking sequence to sequence neural networks and just throwing data at it and hoping for the best. That works in lots of applications of machine learning, but I don't think it's going to work here. So we're going to need new architectures to do dialogue properly. And then with better architectures for dialogue, a better linguistic theory, then we'll actually start seeing systems that can be said to understand language in context, and actually have real conversations. And then from there, we're back to the first part of the question: how to get this out into practice, how to actually have chatbots, not replacing nurses and doctors, but helping nurses and doctors by talking to their patients, which is, by the time those systems are ready, we'll still be struggling with questions related to explainability and scalability, generalizability, and those types of things.
Thank you so much. That definitely makes sense. AI itself just is a black box right now. A lot of people say, and just being able to explain it to real people who are using it would be ideal. Thank you so much.
Thank you for your question.
Thank you. I think we have a few AI enthusiasts here beneath us for sure. Okay, great. So now it's actually time for, I think Hetaf is going to be the one announcing the winning team. So
actually, Lisa, before that, could we do the raffle winners first?
The quiz winner?
No, we had a raffle planned out for some gift cards on this.
Okay, sure. Yeah. Let's do that then.
Daniel.
I can do that. So, hi everyone. I'm Daniel, the VP Finance of UTMIST. So yeah, I will announce that the winner of this raffle ticket are Yuchong Zhang and Afnan Rahman. So I'll say that again. It's Yuchong Zhang and Afnan Rahman. So if you guys are still online, please. Right, so I'll send this our email address to the chat. So if you guys are still online, please reach out to us using this email address, and I'll send you guys the Amazon gift card. So congratulations.
Great, well, congrats to the raffle winners. I was even so surprised to me, so great idea. I hope you'll enjoy your prizes. And now with that, I think Hetaf, I think you can go ahead and announce the big winner of this event.
Sure. So can you all hear me now?
Yes.
Great. So first of all, I'd like to say that all the projects were spectacular, and all the participants do deserve an applause for all the hard work that they put in. And I really hope that all of you learned a lot in this competition. But unfortunately, we can only have one winner, and the winner of this competition is Team Nova.
Congrats, Team Nova. Yes, I think this deserves a proper applause. I think if we can unmute us and give a proper applause to well done, Yati, and congrats. But also, of course, as Hita was saying, congrats to the other teams. I think the main goal of this was anyways to give you a chance to learn. And I hope that's what you did through participating in the challenge. So the prizes is a little bonus that Team Nova can win. I don't know, Aditi Nyati, if you want to say something.
Yeah, thank you so much.
Thank you all. This was great learning about natural language processing and being able to participate. Thank you.
Right. And just to add on to this, yeah, like all the judges have come up with a concise feedback for your project and what we really liked about your project. And, one of the main criteria that actually, set you apart from the crowd is that your pitch was really well structured. That's something we all loved. And the fact that you had given all the audiences a tour of your thought process using the step-by-step approach of your project. Even though that's not very necessary for a technical audience, that is really, really important when it comes to getting your idea out to the general public. So that is something that's really appreciable. And it's often called that prototype is like a topping on the pizza, and you really nailed it because your prototype was really well aligned with your slides and your pitch. And so that really set you apart.
Thank you so much.
Great, thank you. Thank you, Hita. Congrats again, Aditi and Nyati, Team Nova. Well done. And with that, I'm only going to share the information for the next mini sprint, which is going to be our final one. So the fourth one is going to be in ethics and AI and interpretability. So of course, Team Nova, Team Geyser Sharan, Team Innoftech. I hope I'm going to see you again next time. And of course, anyone else that has participated today, if you got interested in maybe trying out a challenge yourself, the way it works is we're proposing different models for you to complete on Microsoft Learn. And then you have a little challenge to complete. So a deliverable, usually just a project idea to submit around that topic. And then we invite a couple of teams. The best teams will be invited to the event to present. So the fourth mini challenge will start tomorrow. The submission deadline is on May 21st. And the event will then be on May 30th. So yes, so if you're interested in joining, do that. Everyone also can receive a Microsoft certificate voucher. So everyone that's participating, you have the chance to complete an official Microsoft certificate, which usually costs around $100, I think. So that's a great chance for you to add that to your CV as well. And yeah, thanks so much, everyone. Thanks for UTMIST again. Thanks for your great support. Frank Rudzicz, thank you for joining us. All the judges, of course. My little assistants in the background, Calvia. Thank you. As always, you did a great job. And of course, Juliet, also the judges. Thank you so much. And yeah, thank you for everyone for joining. And I hope I'll see you again next time.